I had to check to see if my AirPods are connected correctly.
Yeah, that's all we do. Do we talk?
Okay. All right, here we go. Good morning. Does this mean to go in the bin?
Yeah, I thought Maggie was walking by because you talked to her.
All right, here we go.
But no.
Welcome back. All right. We're talking about spheres today, volume and surface area of spheres. We want to be able to calculate each, and they are formula driven, so super easy. We have a few parts of the sphere that we want to make sure we understand. First, a sphere is a solid in which each point is equidistant from the center point. So much like the Earth's core, which is at the very center of the Earth, a sphere has a central point. And from that center to the edge of the sphere, what is that known as? The radius. So it's the same as in a circle, R-A-D-I-U-S. But that radius, it doesn't, just go to the equator, so to speak. It's the same distance to there. It's the same distance forward looking at you. When I go out this way, it's the same distance to this point on. It's everywhere around. That radius is the same. It's hard to visualize on a two-dimensional page, but that radius goes in every direction from the center point, okay, anywhere on the sphere, okay. So the radius goes every which way, and then of course we have this that goes from the top through the center and all the way to the bottom. What do you suppose that's called? Diameter. Very much the same as in a circle. And again, as long as it goes through the center of the sphere, from one edge through the center to another edge in every direction, that diameter is the same. Okay. All right, that central point is called the center. And we also have the great circle slices the sphere into two hemispheres. This is called the great circle, also known in Earth as the equator on Earth. Yeah. So the great circle goes all the way around. And we have two hemispheres, much like on Earth. We have the northern hemisphere and the southern hemisphere. All right, so we want to be able to find the volume of each sphere below. And we will also ask about the surface area of each sphere below. And of course, we have some pretty nice formulas for each. So the two formulas here are right here. The volume is 4/3 pi r cubed. So volume, length times width times height, we get cubic units. All right, when we're talking about volume, things are cubed. And here you can see, for volume, our radius is cubed to the third power, much like volume. That's how we get our centimeters cubed or inches cubed, because we're cubing the radius. So surface area, and the reason I asked for a softball or a baseball is for this picture right here. I did put the picture on here. It's pretty small, but the surface area formula is pretty interesting where it comes from. And so surface area, again, is the area that surrounds the object, okay? And if you think about a baseball or a softball, and you imagine that stitching that goes all the way around, okay? If you were to get creative and tear up all those stitches, then pull the skin off of the softball or baseball. It comes apart in two panels. All right, and these are those two panels. And what you can sort of visualize from the picture in your notes is that they almost appear to be those little panels. It looks like we have four circles. And that's where the formula comes from. So there are four circular shapes that create that sort of skin that goes around the ball. All right. So again, pi r squared is the area of a circle. And how many circles make up that panel of fabric? A panel of leather? 4 of them. All right. So that's where that comes from, which kind of nice to have a little idea of where things come from. We also have some formulas for hemisphere, which we'll talk about in a little bit. All right, so let's look. Let's just do number 2. On number 2, we want to find the volume of the sphere. So what is the radius of the sphere? 11. 16.5. Okay, there. 33 divided by 2 is 16.5 for the radius. 33 is the diameter, goes all the way across. 16.5 is the radius that goes from the center out. So if we want the volume, we get to use our volume formula. So we have 4/3 times pi times our radius cubed for volume. Pay attention to the cube. All right, and we can type that in pretty easily. 4/3 times pi times 16.5. See, I did it there too. Cubed, not squared. All right, so I get 18816.6 if I'm rounding to the nearest tenth centimeters cubed. And I don't know that I mentioned that in this class. I was very careful about it with my 8th graders who did this a couple weeks ago. Now, this is 16.5 centimeters that I am cubing. And so those are units that are also getting cubed. All right. And so centimeters times centimeters times centimeters is how we get those centimeters cubed. Because they are actually in the formula. You can keep them along for the ride, if you will, which is kind of nice. All right, we want to find the surface area. Let's do number 4. Surface area of the figure. What is the radius? The radius is 12. The diameter here is 24. The radius is going to be half of that, so 12. And we want surface area, so I'm going to use my surface area formula, which is 4 pi radius squared. So 4 times pi times my radius squared. And again, you can think about it as millimeters being squared. And that's going to be millimeters squared when we're done. So we have 4 pi times 12 squared, which is 1809.6 millimeters squared. Okay, questions on either of those? Our formula is great. They are great, but also those are more things to memorize, right? These ones, how relevant are these? The volume of a sphere gets used, but not so much surface area, nor either of these. But so for a hemisphere, what is a hemisphere? Half a sphere, yeah. So a hemisphere is half a sphere. And you can see that if we have a hemisphere, it's half of 4/3. What's half of 4/3? 2/3. All right. So we just took 4/3 and instead of 4 of them, now there's only 2 of them. All right. 2/3. Pi r cubed. And then for surface area, now it's interesting. Why did surface area go from 4 little circles to 3? Weird, huh? Well, you can imagine if we just wanted half of this sphere, okay, then we'd only want 2 of these little circles. Well, there's half the sphere, right? Okay. So the half is the bottom portion. But surface area includes the area on top. So that's the other circle we need. That's why there's 3. Does that make sense to you? Yeah? Okay. So, there we go. We got new formulas for this. So number 5, the volume of the hemisphere. Again, this is our radius. It's 5. So volume is 2/3 pi times radius cubed. So 2/3 times pi times radius to the 3rd power. And I'm getting 261.8. And that is kilometers cubed. I can't even imagine a cubic kilometer. It's huge, right? I think you go one kilometer out, 1 kilometer to the left, and then 1 kilometer up, and make that into a cube. And it's pretty big. It's giant. Okay. All right, so page. All right, find the surface area of each hemisphere. Find the surface area. What was the surface area for a hemisphere? 3 pi r squared. Very good. 3 pi r squared. Let's look at number 8. What is the radius for number 8? 6.1. Very good. 12.2 divided by 2, 6.1. So the surface area is 3 times pi times 6.1 squared. 3 times pi times 6.1 squared. 350.7 centimeters squared will do. All right. We do.
Yesterday.
Well, today you have a worksheet, so you actually do need applications. So let's talk about the number 9 here. The volume of a sphere. Oh, find the volume of a sphere. So we want to know the volume. That's what we're trying to figure out. What's the formula for the volume of a sphere?
3 times pi times radius cubed.
Good. Volume of a sphere. 4/3 pi r cubed. I know I have to use that formula eventually. But they tell me that I have a great circle of 201.06 square inches. The great circle. Yes, very good. You can imagine right here from these pictures, right here, the great circle is this thing, that circle that goes around the widest part of the sphere. It is exactly like circumference, but it actually it is a great circle area. So really, it's not just the around distance, it's actually the area that they're giving us. So if they just gave us length units like feet, here they're giving us area. That great circle area is really a circle. So that area for a circle is pi r squared. What am I going to do with the 201.06 square inches? Yeah, that's the area. So 201.06 equals pi radius squared. What do we do next? Divide by pi on both sides. Those pi's on the right cancel out. In my calculator, I'm going to do 201.06 divided by pi. And I get 63.999. What is that?
63.1.
It's really 64. Right? Yeah? Really, 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 really close to 64. That would round up to 64. Okay. Equals radius squared. And then we need to do what? Square root both sides, which means the radius is 8. And now what do I do with the radius? Plug it in to find the volume. So to find the volume, we have 4/3 pi times our 8 cubed. So really, thinking about units can be really, really helpful. They gave us square inches, so I know I'm going to have to use some sort of area formula. So really good things to think about. All right, 4/3 times pi times 8 to the third. 2144.66. I did that just because there's a 0 there. That's a good natural place to stop a decimal point. So that is volume. So that's going to be inches to what power? Cubed. Inches cubed when we talk about volume. All right. Ooh, find the surface area of the figure to the left. Interesting. I don't really think that, okay. I actually don't think her work is right. No, it's fine. What two shapes do we see in this figure?
Triangle.
A triangle or a cone? All right. So we have a cone and a hemisphere. All right. Now, when I think about surface area, I'm thinking about the surfaces around the outside, right? And so for my cone, that is so funny what she did here. Interesting. Do we remember the formula for the surface area of a cone? Surface area of the cone, what was it?
3/4.
No, that you're thinking.
No, it's 1/3 pi r squared times height.
So that's volume of cone. Pi r squared plus pi r l. All right, that was the surface area of a cone. What's the pi r squared part? Yeah, if you got your cone, it has a base, right? Do we need that base? We do not need that because that's on the inside of the shape, right? I don't care about the area of the inside. I just want the area of the outside. So pi RL, this is the circle part. Pi RL is the sides of the cone. That's the sides. Side. I guess there's only one side really that's continuous. All right. So we do need that pi RL. And then the hemisphere. Well, what was the formula for the hemisphere? 3 pi r squared. Good. And again, when we talked about that, what's the formula for the surface area of a whole sphere?
4 out of 3.
4 pi r squared for a hemisphere, or for a whole sphere surface area. 4 circles, 4 pi r squared. Okay. And I said that this hemisphere, the formula has 3 pi r squared. What's the 3 for?
The 3 sides of the
The third one is for just the top circle, right? Do I need that top circle? Nope. So this hemisphere is only half a sphere. I don't want to include the circle on top. So this surface area for the hemisphere is only 2 pi r squared. Again, the 3 was for the circle on the very, very top. Does that make sense to you? Okay, a little bit? All right. So here, to find the total surface area, we want to find the surface area of the cone, and we want just the side of the cone, not the whole cone. I don't need the cap. I don't need that circle on top, or in this case, on the middle. And so it's just pi times radius. What's the radius?
4.5.
4.5. And our slant height is 13. So pi times 4.5 times 13 is 183 point, I guess I'm going to do 7, 8, it goes on, but. All right, and then the surface area of the hemisphere, and again, it's not the top, it's just that southern hemisphere, all right? So that is just half the sphere, so it's just 2 pi radius squared, so 4.5 squared. 2 pi times 4.5 squared, 127.23, 4, yada, yada, yada. Okay, goes on and on and on. And I'm just going to add those two together then to get the total surface area. So just adding these up, I'm going to go ahead and use my calculator to highlight and bring down the whole decimal, very useful trick. so that we do not round until the end. 311.02, I guess. And this would be meters squared. Interesting. Oh, that is the same answer she got. She just did it a lot more challengingly. Do you want to see the work she did? Yeah. Right? So this is why it's, I think it's useful to just think through what your formulas mean for a little while. Like, what does that really mean when we're looking at those formulas? All right, cool. I'm glad that worked out. All right. Henry's silo, the Henleys have a silo on their farm to store grain, assuming the entire space is to be used. What is the maximum amount of grain that the silo can hold? If they're asking for a maximum amount of grain, is that a measure of surface area or volume? Volume. Okay. So we're thinking about maximum volume. So when we use our formulas, we want to make sure we're using volume formulas. Okay, what two shapes do we have here?
Hemisphere.
Hemisphere, and a cylinder. All right. Okay. So this is, we need the volume of the hemisphere. Well, how do we figure out the volume of a hemisphere?
Two-thirds times pi times radius cubed.
Very good. 2/3 pi r cubed. Good. That's volume of the hemisphere. And then volume of the cylinder. What is the volume of a cylinder?
2 pi r cubed plus 2 pi r cubed.
That's surface area. Pi r squared times height. Very good. Pi r squared times the height. Very, very good. Okay, now that we know the formulas that we need, that's pretty easy. 2/3 times pi. What's our radius for our hemisphere? 11. So that radius is 11. Very good. So 11 cubed. So I'm going to put that in. 2/3 pi times 11 to the third. And we get 2787.639, on and on and on. Okay. All right. Volume of the cylinder is pi. We know our radius is 11. We already did that. So pi times 11 squared times, what is the height of the cylinder?
45 minus 11.
45 minus 11. Very good. You'll notice how I drew the radius vertically. All right, that radius is 11. I can draw it vertically. What is 45 minus 11?
34.
34. So that height of the cylinder is 34. And so I'm going to write that in. The height is 34. So let's see. Pi times 11 squared times 34. And I get 12924.512. That's a lot. And what do we need to do with these two volumes? Add them up. And so again, I'm just going to use my calculator and pull in the entire decimal. Highlight and hit enter. Highlight it and hit enter. And we get 15712.15. Feet cubed. Okie dokie. Do you have questions for me? All right.